So as you know, the emergence of NFT allows creative people to show themselves very brightly in the digital world. Show a method of combining painting and programming, if I may say so. This method help you quickly create a collection with a huge amount of the unique NFT. You can easily list that these NFTs on the slide definitely have some similarities, but no duplicates. And performing we prepare the task that only requires you to know JS language and need Rust and Solidity you won't need. The link below, go to our repository in GitHub, to our workshop. So we getting close to our project. A few words about Uninque Network chains. So Uninque is NFT blockchain for games marketplace, and our mission is to enable developers to create the next generation of NFT applications using our advanced NFT tools. As you can see, Uninque is our production chain. Quartz is a chain for Kusama, testnet Polkadot. Opal is our testnet for development, and Sapphire is our future chain. You girls will develop on Opal as me, and you can take free token from this Telegram bot. And we are developing our own library, SDK, to interact with a low-level API. Our SDK library help you mint collection and tokens and manage your account and wallet balance. So it's an NPM package that you can install by this link, and our code is open. So here at the second line, you can hear docs link. It can be very helpful because you can see many examples about our SDK and interaction with this library. And you can see also a link to our Telegram with support. Our library makes easy to interact with the blockchain. And one more thing is important, that we can developing, and then we change endpoint and can go from test to production mode. It's change the endpoint. We have also you can see our feature, our API, and
NFTs that we're putting them together. And so, as Anna will be presenting, some of the programming shows this compositing or general programming task, but then there are the most interesting parts, which is how to apply the SDK on this set.
The key idea is that you have examples: background, mask, heads, and you will combine this and generate unique NFTs. And that I can notice demonstrate a very good idea of nested NFT. So you can have personage, character, it's NFT, and this NFT can have any heads or weapons or someone else that it was a nested NFT to the person. So it is very useful for games, game developing, and others.
But in this assignment, you will not need to use nesting. I mean, we're mentioning it here as a feature because it's interesting, kind of a way to expand the idea. Because you have a very short programming stint, it will be much more interesting to use this approach that we're using, because it will allow you to quickly generate a lot of NFTs and images, and so you can concentrate on the creative part of how to put together interesting images.
And for storing our NFTs, we use a global decentralized file system, IPFS. After successful your task, you can observe results of our NFT on our project scan. You can go to scan with this link on the screen. So by me, that's all. And now I pass the floor to Anna, my colleague, who will introduce you in detail about task itself. Thank you.
Let's start. Open your editor. I use WebStorm. Download the workshop from GitHub with command git clone link to repository. In the console, open folder with NFT workshop with command cd and workshop. Next, install dependency with command npm install. Here our project. You copy the config example JS file and rename it to config.js. In the config, you need to set your settings. Let's take a closer look at the important nodes in the config. Creation forms are in images folder.
So these are the elements, the elements that we'll be enumerating and describing in the schema, in the properties, yeah.
image prefix set generated image file name. The file name is completed with its serial number. The attributes field in console in config.js that contains a list of layers and variation of each layer. The layer name will be used as the name of the token attribute. The value will be used as the value of the token attributes. Add your seed phrase to the config.js in owner field, replace Alice. A seed phrase is an ordered set of 20 words that is generated by your wallet and store all the information that can be used to recover your wallet. You can generate a seed using the Polkadot.js extension, or you can use development-specific Alice account.
So the Alice account is actually a shorthand for a developer account, which is free to use. Any one of you can use. But the mnemonic phrase that you get from creating a wallet is actually what you put in the owner seed, and you put it simply between the quotes. No slashes there, just word and space, then word and space, then word and space, in quotes with the 12 mnemonic phrases.
So, the desired count field specifies the number of tokens to be generated. Our workshop consists of 4 channels, 4 steps. Step first, NFT generator. The generator NFTs function first calculated the total number of possible combinations of pictures. Then accumulates the attribute value numbers for each future NFT in the loop. A random selected and on its basis the numbers of attribute values are calculated. The algorithm must ensure the uniqueness of each set. Save results in file. Run script with command node file name. The sets are written to the file generated nfts.json. The file contains indexes of variation of each layer for future NFT.
So this is used by the program. Extremely tedious to create this file by hand, so we're generating it here automatically.
On step 2, read sets of number generated in first step. On step 2, we image generate. First a pool of threads. The maximum number of threads is set in images in parallel parameter the config. The parameter is set to the maximum, the number of virtual or logical CPU core. You can use the maximum number to use the full computer. I will set this parameter to the full be executed in the set in the scripts generated image worker here. In the loop of each set, we comment the name of the picture. In the get image data function, we collect names of the part pictures for each NFT. We put in queue the task of combining the picture parts into a single picture. Run the script with command node step 2 image generator.
So as we saw, some very handy programming there, how to use threads to optimize the compositing of all the elements through a schema that we have, through actually a collection scheme that we made to how to put together these images. And here we see the results of the generation of that. Remove the how many threads you want to use. If you use too much, you will overload your system most probably. But then again, if you're generating 1 million NFTs, which wouldn't be an issue at all, yeah, it probably makes sense to take more threads into action. But you know, in that it can quite computer.
Thank you. After the script, we can observe our pictures in the nft folder. Here, picture. Next, step 3. In step 3, we send pictures to IPFS storage and create a collection. We make archive of pictures in order to send less data, and our SDK has a special command to upload the archive to the IPFS storage.
So this is a sweet utility. I was surprised I didn't know this. Anna showed me when we were doing the preparation for the presentation. It is actually part of the SDK, the ability to encapsulate data that is being pushed out to the IPFS into a zip archive, which is then applied and accessed as it is. So it's a very interesting.
Next, we initialize SDK. We only need knowledge of JavaScript to interact with the chain using the SDK. Able to sign transactions, confirm our action, we passing the account seed there. for initializing the SDK, you also need to pass the REST endpoint. Because our SDK interacts with the REST, which is interact with the chain.
So here, essentially, the keyring palette provides a way for us to use our mnemonic to sign the extrinsics on the blockchain, which actually abstracts the whole complication of the security issues that are a big part of how to properly initialize and sign a transaction in the Polkadot system. So making this easy is really a boon. So this is a central part. This initialization part here is very important. I just wanted to make a note in terms of starting up the whole system and getting the SDK initialized to do further operations on the blockchain.
Thank you. To upload image to IPFS storage, we use the upload. Next, we create collection with creation function from SDK. In function, we pass argument address, future owner of collection, cover picture. If we want cover our collection, next URL template. It's a pattern for token image names, name and description. You set them in config. We create a new collection with unique schema. The collection schema allows you to set all for token attributes. Then when creating a token, the value of a token attribute will be a real number of the property value in the schema, which will make the token more lively. More details can be found in the documentation.
And in this, the layout of the schema is actually what you want to still a bit more. You want to expand capabilities. So schema provides you the ways to set advanced properties, whatever they might be, options that an NFT can provide in terms of these attributes, mutable, immutable values. Are all specific details can be found in our documentation. So that's the place where this is being defined.
Yes. This function creates a collection on the chain. After images uploaded and available at this link. Вот они загружены. Here picture.
Yeah, perfect. That we see that this is the way to check, of course, that they have finished uploading and that they're available on the IPFS network.
The collection ID will be logged and written to the generated NFT data.json file. Here. Next step. At this step, we mint tokens. We initialize SDK again using our SDK's last token ID function. We request the highest token ID in the collection so that we don't create duplicate tokens if we have already called the script before. We accumulate data tokens in the array. To create a token, you need to specify the address of the token image. We use the short notation. This value will be inserted into the template specified when creating the collection, and the full address of the image will be obtained. Also, to create a token, you need set of the encoded attributes value. The token attribute name is represented by the serial number in the attribute array in the collection schema. The value of a token attribute is specified number of the attribute value schema. It's number of. To generate tokens, we use to generate tokens, we use our SDK's create multiple function. Generation is possible for a whole set tokens in one request. We pass parameters address, ID, and call to we will take 20 seconds or more because writing a block to the chain takes 20 seconds. Then rest to which the SDK is connected will parse the new blocks of the chain and send to token creation result back to the user.
The 20-second time is a characteristic of both the Polkadot current network as well as our current. This is a number which will go significantly as the network and develops further.
Okay. Run script with command not the file name. Step 4, create items.
So in this function, some very interesting things are happening in terms of we're using actually call up the tokens that we'll be generating, and then in the end we use a very convenient function that is just a one call function that mints the whole in one call. So you don't have to the minting for loop or something like that and to cycle across for each token. You can actually pass the whole structure of the NFT a way to segment how many of them you want to mint at a certain stage to push 1 million minting requests on a to say, but still it makes mint extremely simple.
All IDs of created tokens will appear in logs. After creating the tokens, you can look the collection on scan. Here, our ID collection also here. And here our collection on scan.
So this is the live generation happening. This is the collection being minted currently.
And token attributes here. That's all. Thank you.